Okay, so you're prepping for that senior software engineer interview, and system architecture is, well, it's a big deal, right? It can feel like this massive area to cover.
It really can.
Yeah.
Absolutely.
But we want to give you a clearer way to think about those key architectural decisions that often come up, you know?
Yeah, the kind of things you might be asked about when you're designing a system or explaining choices in an existing one.
Exactly.
So it's not just about knowing the pieces, but the why behind how it all fits together.
Right, the reasoning, the
trade-offs.
that deeper level of understanding.
Okay, let's start with a really crucial concept.
Okay.
Handling sensitive data.
Right.
Imagine you're working at a company that processes credit card information.
Yeah.
We'll call it PaymentCo.
Okay.
Right away, security and compliance are going to be top of mind.
Huge. Yeah, absolutely.
What's a key insight here that PaymentCo really got right?
Well, one of the things PaymentCo really nailed was isolating that sensitive data. They basically created different zones in their system.
Okay, zones?
Think of a green zone.
For parts that never touch the credit card. Details things like managing merchant information or scheduling payments.
Right. Completely separate.
Yeah.
So,
And then you have a red zone, and this is where all the full credit card data lives.
okay.
For PaymentCo, their payment service was the only component in this red zone.
Got it.
The only part allowed to see those sensitive details.
Okay. And to make this work,
The gateway was key.
the gateway.
Yeah, it acted like this really careful traffic controller,
Sure.
directing requests to the right service, but critically ensuring that only that payment service in the red zone ever saw the complete credit card data.
And I think the real takeaway here is how this impacted their PCI burden.
Massively, yeah.
So by keeping all that sensitive data locked down in that single red zone,
Right.
PaymentCo dramatically reduced the scope of their payment card industry compliance requirements.
Yeah.
Instead of their whole system needing to meet those strict standards and go through all those audits, only that isolated red zone was in scope.
Yeah, you can imagine the difference in complexity and cost.
Oh, absolutely.
Absolutely.
But this raises an interesting question.
Yeah.
How do you ensure that sensitive data never flows into those non-sensitive green zone areas?
Yeah, that's the key. Right.
Because if a service in the green zone could somehow request or get access to credit card information,
Right.
that carefully built boundary is broken and all those compliance benefits are lost.
Exactly.
Yeah.
You've got to design your interactions to prevent that kind of leakage.
That's a really good point.
It's essential.
So that highlights a key principle in designing secure systems. Now let's shift gears a bit and talk about a foundational architectural pattern that many engineers encounter,
Okay.
the three-tier architecture.
Ah, yes, the classic.
You've probably seen this one quite a bit in your experience.
Most likely, yeah, it's quite common.
So what is it?
Well, the traditional three-tier architecture, as the name suggests, divides an application into three logical layers.
Okay, layers.
You've got the front end, which is what the user interacts with, often a web UI. Then you've got the back end, which contains the core business logic and service layer.
Okay.
And finally, the database handling all the data storage and management.
Got it. Front end talks to back end, talks to the database. Pretty straightforward, right?
Yeah, in essence.
So what are the advantages of structuring things this way?
Well, first of all, it promotes modularity changes in the front end, for example. Shouldn't necessarily require major changes in the back end or the database.
Makes sense.
Right. Then there's scalability.
Mm-hmm.
If your back end is under heavy load, you can often scale those servers independently of the front end or the database.
Okay.
And each layer can be optimized based on its specific performance needs.
So it's all about that separation of concerns.
Exactly. It makes the code base more maintainable and the overall system more flexible.
Right.
In the long run.
It sounds like a pretty solid and widely adopted approach.
It is. It's a classic for a reason.
Okay, but let's consider a scenario where these service boundaries get a bit, well, let's say interesting.
Okay. I like where this is going.
Imagine a company with a website being built by a team in California
Okay.
and a separate team in Brazil responsible for a data access service that sits between the website and the database.
Got it. So we're talking about a service boundary split across technical seams.
Yeah.
You have a clear boundary between the front-end website and this data access service, and another between the service and the database,
Right.
even though they're all part of the same system.
Right.
The goal here, similar to the three-tier model, is modularity, scalability, maintainability, allowing those teams to work independently.
Makes sense on the surface, right?
Yeah, on the surface, it sounds great.
California team handles the user-facing part. Brazil team focuses on getting the data.
Right.
But I remember reading about potential pitfalls with this kind of split, especially when it's done in a particular way.
Absolutely.
What should someone interviewing for a senior role be aware of here?
The real danger lies when this split is horizontal,
Mm.
meaning you're taking what was essentially an internal API within a single process and turning it into a separate service. So in our example, making that data access service just a thin layer, exposing low-level data operations,
Right.
that's where you can run into trouble.
Okay, I'm picturing that.
Yeah.
The front end is constantly needing lots of little bits of data.
Yeah.
So it ends up making a ton of back and forth calls to this data access service.
Yeah, and that's the problem.
That sounds inefficient.
It is. It results in what's often called a chatty interface,
Oh, yeah.
with brittle, low-level communication, often using something like RPCs.
Remote procedure calls?
Right. Imagine the overhead of establishing a network connection and deserializing data for every little request.
Right, for each tiny piece of information.
Exactly. And that latency really adds up. Performance can suffer significantly.
Ouch.
You might even need to implement complex batching mechanisms just to mitigate the overhead.
To try and make up for it.
Yeah, it's not ideal.
Yeah.
This kind of overly layered architecture has even been humorously dubbed as an onion architecture.
Onion architecture.
Lots of layers that can make you cry when you have to work with them.
Okay, so for someone in this interview scenario,
Yeah.
what's a better way to approach this kind of team and technology split that they could suggest?
The alternative is to think in terms of vertical slices.
Vertical slices.
Instead of splitting based on technical layers,
Okay.
you divide the system based on business functionality.
Got it.
So in our California-Brazil example, the California team could own an end-to-end slice.
Okay.
The specific front-end components and the related data access logic needed for a particular feature.
Right.
The Brazil team could then own a different vertical slice,
Mm-hmm.
encompassing its own front-end parts and data access needs for its functionality.
I see.
This gives each team true ownership and reduces those brittle dependencies.
Okay, so each team has ownership of a complete feature or business capability.
Precisely.
From the user interface all the way down to the data.
Exactly. It reduces those dependencies between horizontally layered services and allows teams to be truly independent, which is a key consideration for senior engineering roles, where you're thinking about team structure and efficiency.
Yeah, absolutely. This leads us to a broader point that's definitely relevant for your interview prep.
Okay.
How else can we think about defining microservice boundaries beyond just the business domain, as we often hear about with domain-driven design?
That's a great question. And it's important to remember that while domain-driven design is a powerful tool, it's not the only way to look at microservice boundaries.
Right.
There are other factors that can and should influence how you break down a system.
So what are some of those alternative approaches?
Well, one that comes up is volatility-based decomposition.
Okay. Volatility-based decomposition.
The idea here is to identify the parts of your system that change most frequently,
Got it.
and then extract that functionality into separate services.
Okay.
The thinking is that by isolating these rapidly evolving components,
Mm-hmm.
you can iterate on them more quickly without impacting the more stable parts of the system.
Makes sense.
Right. The potential benefit for time to market is clear.
Right.
However, a decomposition driven solely by volatility might not align with your scalability needs.
Okay. How so?
Well, the parts of the system that change most often aren't necessarily the parts that experience the highest load.
Right. They're not always the same.
Exactly.
The source material also briefly mentioned bimodal IT in this context.
Yeah, bimodal IT is this idea of separating stable and agile systems.
Okay.
But the risk is that those stable systems, often crucial legacy components,
Right.
what we refer to as systems of record,
Okay.
they don't get the necessary updates,
I see.
potentially creating a bottleneck for those fast-moving agile parts.
So while considering volatility can be useful,
Absolutely.
it shouldn't be the only factor.
No, especially if scalability or the need to evolve core systems are important aspects.
Okay, another interesting factor that ties back to our initial PaymentCo example is data-driven decomposition.
Right.
So how does the nature of the data influence architectural boundaries?
Well, the nature of the data you handle can be a significant driver for decomposition, especially when dealing with sensitive information like PII, or as we saw with PaymentCo credit card data.
Right, right.
Here, the primary goal isn't necessarily about volatility or even strict domain boundaries,
Okay.
but about limiting risk and simplifying compliance with regulations like GDPR or PCI.
Right.
The PaymentCo example really highlights this.
Uh-huh.
By isolating the credit card data handling, they reduced their PCI scope dramatically.
So the need to protect sensitive data can be a powerful reason in itself to create service boundaries.
Exactly. It ensures that only specific services have access to and are responsible for managing that information.
Right.
This minimizes the potential for breaches and simplifies the often complex requirements associated with handling such data.
Okay, then there's technology-driven decomposition.
Right.
This one seems a bit more straightforward.
It can be, yeah.
But are there nuances someone preparing for an interview should keep in mind?
Definitely. This comes into play when you have a need to use different technologies for different parts of your system. For instance, you might need a high-performance component written in a language like Rust, while the rest of your system might be in Python or Java.
Mm-hmm.
Or you might need to utilize different types of databases with different strengths.
Got it.
The key thing to remember for your interviews is the caution against relying solely on technology for defining boundaries.
Okay.
The traditional three-tier architecture, while seemingly logical from a technology perspective,
Right.
can sometimes lead to those horizontal splits we discussed earlier that don't always align well with business needs or lead to the most flexible or easily maintainable systems.
So technology can be a factor,
Absolutely.
but it shouldn't be the primary one.
Not the only one, though.
Okay, finally, let's talk about organization-driven decomposition and the idea of Conway's law.
Conway's law, a classic.
How does the way a company is structured influence its software architecture?
Well, Conway's law essentially states that organizations tend to produce designs that mirror their communication structures.
Yep.
In other words, how your teams are organized will likely influence the architecture of your systems.
That makes intuitive sense.
Right.
Teams working closely together are more likely to build tightly coupled systems.
Exactly.
So how can this understanding inform architectural decisions?
When defining service boundaries, it's crucial to consider team ownership.
Okay.
Ideally, a service should be owned by a single team
Right.
to avoid the challenges of shared responsibility.
Makes sense.
And the source even suggests that in some cases, you might need to adapt your organizational structure
Oh, wow.
to better support the desired architecture.
Right.
Interesting, right?
Yeah.
If you're proposing an architecture in an interview, briefly touching on how it aligns with potential team structures
Right.
can be a strong point.
And if the organization changes down the line,
Good question.
does that mean you have to re-architect everything?
Not necessarily a complete re-architecture,
Okay.
but organizational changes can definitely have an impact.
Like-
If a single microservice suddenly needs to be owned by two separate teams, it might be a sign that it needs to be split.
Okay.
Conversely, sometimes organizational changes might just require reassigning ownership of existing services to different teams.
I see.
It's a dynamic relationship, and being aware of this interplay is important for senior roles.
So it's a bit of a dance between the desired architecture and the organizational structure.
Exactly. They influence each other. Considering Conway's law can help you define service boundaries that align with team responsibilities,
Right.
leading to more effective development and ownership. This is a key point to keep in mind as you think about system design in your interview preparation.
Now, we've talked a lot about defining boundaries between services.
Right.
What about layering within a single microservice?
Good point.
Is that generally a good practice, or are there pitfalls there too?
Layering within a microservice, separating concerns like presentation, business logic, and data access can be beneficial
Okay.
for code organization and managing complexity within that single unit. However, and this is crucial for your understanding of microservices, this internal layering should not be the primary way you define your microservice and ownership boundaries.
Okay.
That's where you can run into the issues we discuss with horizontal splits across technical seams at the service level.
Got it.
Think vertical slices for service boundaries and internal layers for code organization within those slices.
So layering inside is okay for keeping your code tidy.
Yeah, that's a good way to put it.
But layering outside as your main service boundary strategy can lead to trouble.
Correct.
We've covered quite a few different ways to think about defining these crucial architectural boundaries. It sounds like there's no one-size-fits-all approach.
You got it. There isn't.
Yeah.
There's no single right way to define boundaries. And in practice, you'll often find yourself mixing and matching these different approaches.
So when you're in that interview and asked about architectural decisions,
Yeah.
it's not just about reciting patterns,
No, not at all.
but explaining why a particular approach was chosen and what other factors were considered.
Yeah. Exactly. It's about demonstrating that you understand the principles behind it all.
It's about showing that you can think critically.
Precisely. It's about demonstrating that you understand the principles of information hiding managing coupling and cohesion, regardless of the specific mechanism you choose.
So domain-driven and organization-driven boundaries are often a good starting point.
They often are.
But factors like volatility and technology might also come into play,
Absolutely.
depending on the problem you're trying to solve.
Right. The key is to show that you're considering multiple dimensions.
So the key takeaway here for anyone preparing for these interviews is to avoid just blindly applying a single architectural dogma.
Couldn't have said it better myself.
Consider the specific circumstances.
Yes.
The data you're handling, the rate of change, you anticipate the technologies involved, and your organizational structure.
All of it.
A well-reasoned explanation of your choices, even if it's a hybrid approach, will be far more impressive than just reciting best practices.
Absolutely.
This has been incredibly insightful, really applicable to anyone prepping for a senior-level technical interview. We've covered data sensitivity segregation, the pros and cons of traditional three-tier architectures, the dangers of poorly defined service boundaries across technical seams,
It's a lot.
and a range of alternative approaches to defining microservice boundaries.
Yeah, we covered a lot of ground.
All with an eye towards how these concepts appear in interview scenarios.
Right, because understanding these concepts provides a strong foundation not only for acing those technical interviews,
Right.
but also for building robust and scalable systems in your career.
Exactly. So as you reflect on all of this in your interview preparation, here's a thought for you.
Okay.
Considering the projects you've worked on, what were the primary drivers for the architectural decisions made? And in hindsight, knowing what you know now, were those the most effective choices?
That's a great question to ponder.
It's worth taking some time to really analyze your past experiences
I agree.
as you continue your preparation.
Absolutely.
Thanks for joining us for this deep dive.
It's been a pleasure.